Welcome everyone to another super fun FPGA live stream. Which cameras is also probably, wait a second, too many cameras. ULX3S here of previous FPGA goodness, previous videos, and yeah, quite some progress as you see. The details always take, which also too many camera scenes. I have freaking too many camera scenes. Anyway, so yeah, as you can see, a full VGA graphic. We have this in the previous video. The icebreaker that we used initially, not enough memory, at least if you do not plug it in with some additional PMODs, some hyper memory stuff. But yeah, I wanted to present you the latest progress if you were wondering. And actually, so this progress, of course, the graphic here is the smallest detail. We have started this in the previous video. This is now full FPGA because the ULX3S has so much more memory, including on this revision 64 megabyte freaking SD memory, also SDRAM controller, previous video. So the huge progress previously, even in probably December or many months ago, I've shown you already some basic graphic on the icebreaker. And so that does not look like the largest upgrade. However, now we are loading this from the SD card, previous video. Initially in the icebreaker, I always had the test graphics in the bitstream of the FPGA, like initialization data. And this is the first time, like today, kind of, sort of, I guess the first time today ever, that we are dynamically loading this data. So what you see on the screen, I can try to plug it in and out again. Can we probably, yeah, let's, it will, I hope the video will sync again if we do not have here some, also helps audio. So we are rewriting or reloading the bitstream, the FPGA bitstream configuration, as well as the synthesized bitstream, as well as the firmware. And we hopefully should, also too many, I need to relabel here my fancy scenes. Then in a minute, when this relatively fast-ish, this means now with all the basic enablement, which as you can see was quite some stuff, and also next actually USB and or also this camera, I guess, right? Also too many. Anyway, keyboard and mouse, certainly that would be even more amazing. So yeah, now we should have here some video, which of course we don't. Oh, no, we have. The test data, so the random garbage there, except the first line, which, yeah, whatever. But the other stuff is expected because actually, I think we probably can switch. So this is included in the bitstream. This is just some initialization data in Verilog as init mem for testing purposes. This is how in all the previous videos I've always had some usually static, except sometimes a tiny little bit dynamic. But anyway, so this is also 8-bit VGA converted here with exact image convert and included hex dumped into the bitstream. But what is now the very new thing, which let me first, yeah, for example, this one, in case you can see this a little bit. So a new test command here is in my firmware stuff. In the meantime, also a little bit C++. So we can now run S for SD card. And the only thing is, I probably broke something a little bit, doesn't always work. So the initialization is still a little bit glitchy because, yeah, okay, whatever. But now this worked. So also, so what you've seen here is this stuff. Also, by the way, as soon as it initialized once, I need to debug this, why this is now a little bit glitchy. As usually, develop quite some new features, and then you have some tiny new little issues. But as you see from the test data, we are parsing, which also can bring you a larger resolution. We are actually parsing this FAT file system here for real. So that means in this position, there's a tiny little bit nicer here, pixel perfect. So this means relatively complex code, including we implemented, because we're not in partially C++ endianness conversion template stuff, previous video. Probably will go there in more detail in following video. But so this are, as you see, all the 8 character and additional Unicode. entries. So this is the real content, and yeah, fun fact, this is out of a Raspberry Pi. This is why here's some other Raspberry Pi nonsense between those files. But we also have here monkey islands.tga. That is what we want to open. We have match here. This is cluster 79,981, and then we are loading this dynamically here, as you see, and this is just what you see. So extremely quite a lot of code coming together here, months of 20% YouTube fun work. For me, super thrilling to see this much stuff coming together. And as more of this basic enablement, we have in the meantime some sound generation, even full direct stream digital PCM playback, video output. One issue, however, is that the usual 90-10% rule, we have already implemented 90% of the features, sort of, with audio and sound. The issue is now only the last 10%, like, take 90% of the time, because a lot of stuff is working in principle, proof of concept. However, I always had the goal of supporting also the icebreaker. That means right now the Verilog, this is also not yet upstream, that I need to clean up the Verilog code so that, for example, it has some parameters so that we can instantiate the video controller, for example, for not only the icebreaker, but also without less memory. Right now we have here, as you see, 64K memory. We even need a little bit more. This is also why at the bottom there's still some not perfect garbage, because we're not yet, well, we need a little bit more memory basically, and the ULX3S even has the memory, just like, yeah, a little bit of improvements. But in any case, the last 10% usually takes 90% of the time as well, because cleanups, and then the cleanups, not only the cleanups always sound so easy, we also parameterizing this takes certainly quite a while of all the typing and testing it. Anyway, I even have here, so the graphic, we could start to write a game, Pac-Man, Tetris, even theoretically port ScumVM to RISCV, or leave me in the comments below. We could totally go crazy. We could write our own jump and run, our own point and clicks there, 2D StarCraft-like strategy game, or all the other fancy stuff. This performance is relatively, so now that this card initialized like correctly and the serial bit stream clocked there correctly, this should usually like always work, at least it did on my testing. It is relatively fast-ish, I would say, and right now this is in the game. You could vastly speed this up, because right now this is on the fly loading this from the SD card, so relatively slow serial SPI data transfer, which it's, yeah, not too bad. It's flickering a little bit, and in a real game you would preload this. Right now we have here 64 megabyte anyway. That is a rough overview presenting you of all the, if you want to do some real production like homebrew, RISC-V, something stuff, then here quite some details to take care of. I hope you enjoy it as much as I do. And yeah, not even counting keyboard and mouse, that we certainly need to do next. So this is the test firmware that you have seen previously here, the output of Claire's PicoSoc test firmware that we in the meantime majorly extended with all our VGA testing. We even have a freaking, you even see this, we even have a freaking hardware mouse cursor there, because certainly that's what we want to have. So among the stuff done today is also wiring up Pellet, because if I could theoretically, yeah, but it takes a little bit of flashing, but so Pellet meaning we usually come up here with a default palette of VGA goodness. It's a good old-fashioned 80s VGA palette of what the VGA cards back in the day had as a default palette. I included the same here for feature parity and having some common PC industry standard to work with. Actually, in the meantime, I load this mostly from the files. This is only for readability. It's basically defining this twice. But today, also actually too much time spent, because I had a stupid typo there and some address in my firmware, but supporting user-defined palette, And this is also the stuff on the icebreaker we run out of the very last logic cell we had there previously. So this kind of stuff, this will be quite some error-prone work of deleting features of the icebreaker. Well, the icebreaker anyway, only with our code here only has 16 colors anyway. But this is the kind of stuff like yeah, we need to parameterize and maybe delete some features for the icebreaker. So yeah, palette loading is just one line basically. Yeah, this is loading, this is rereading. Yeah, not the biggest deal, but on the firmware side, I probably make a dedicated video of the FAT loading, so FAT loading coming soon. But for the test code, this is basically TGA files. So Monkey right now, what I'm trying to do here is also with the microkernel. The long-term goal is, well, also microkernel, because 2020 we need some more reliable kernel. And certainly this is not production quality, like Reliance high real-time something microkernel, verified and formally verified and whatnot goodness. This is right now only homebrew prototyping, but the future would be to use the same definitions of FAT and X2 and BetterFS and whatnot, shared headers in all the projects, so that you have one readable definition of header, because actually the Linux kernel headers are also sometimes not the most readable. This is why, unlike other microcontroller firmware often doing some custom function stuff, I already try to keep this here C-like. How we do this in the future we have to see, but certainly it's a good idea to have this C-like. Then we can use the same firmware of my previous videos, where we have done similar stuff on homebrew as GCC, on Linux compiled for DOS, where we have done even 3D accelerated Verge and Voodoo stuff previously, also certainly coming eventually to the RISC-V FPGA board. So our own video acceleration and 3D acceleration. But certainly, so this is certainly then pretty amazing, because then we could have one game like Tetris, Pac-Man, Floppy Bird, and have one source, hopefully so standard conforming C code that you can just recompile and either run it on DOS or maybe Linux or your other Unix system, and or use RISC-V playground. This is right now, it's only proof of concept, so this is not like error handling is not yet really there, only a little bit. But what I've already written, and probably represent you in more details of the FAT loading of how to do this from scratch. You see a little bit anyway of stuff, but this is really loading all the data from our own FPGA, Verilog stuff on the hardware level, over the SPI serial line there, and reading all the FAT, the file allocation table, and reading all the clusters implemented here from scratch, because you actually will not find. So I basically took the FAT specification and typed in here all the stuff. And so FATnext cluster was totally prototyping like as fast as possible in just an afternoon. I'm actually surprised I got it working in one afternoon, like 2 days or so ago. So yeah, next cluster reading. So, and open here is really, actually right now I only support a root directory. So right now no subdirectory supported, but theoretically not that difficult. And also the Unicode naming, super annoying. Right now, as you see, this is not yet really standard conforming. I have here, so the open, right now it does not really support dot notation. So normally you would open this like this, but because FAT is so extremely stupid that the stuff is actually space filled, and 1, 2, 3, 4, 5, 6, 7, 8. It would take quite some string fiddling to remove the trailing spaces and insert a dot there. So yeah, whatever, a little bit fast prototyping stuff. But what also should probably work, but actually I've not tested yet, but actually I don't have a cable here, but it should probably work. Previously I loaded a WAV file here that is also here already, the BSD song. Did I actually show you that? Actually, right, so the FAT file system loading you have seen a little bit from the OpenBSD, the WAV video. I made already live stream with this music playing from the SD card when we initially enabled that. But yeah, so with this stuff, if you wanted to, you could like start somewhat nearly kind of today, except that I didn't push all the stuff to GitHub yet for the sake of I have some local changes that I've not yet committed due to Icebreaker versus ULX3S. But otherwise, programming-wise, it makes sense to keep this updates of what we unlocked here in terms of graphic short and make more dedicated videos, because one dedicated video would be file system reading from scratch. How does it work there for you to learn something? And the second thing is, for a rekernel right now, this API is also not standard conforming, as in right now, because complexity, you can only read with this code. It looks POSIX-like but right now it only supports reading full blocks. So there you see also from proof of concept to full production ready, all the small little annoying details, as in reading smaller quantities and misaligned. It's actually, we would need to have some caching there. Right now this API is relying on only reading full blocks. And yeah, certainly that is not what you kind of do in a real system, whether homebrew microprocessor or real microkernel. But nonetheless, I'm pretty happy with this progress. I hope you enjoy it as well. As always, leave in the comments below what you find the most interesting, what you would like to see. Basically, we have sound and video image handling now. So yeah, probably actually the whole thing today, the file, by the way, is the TGA Targa graphics. I also, among this, I actually implemented for you to play along at home also in exact image improved Targa support, TGA support for handling Targa files with color palette, color map. Previously, probably I never had a file with this because I actually thought just in this afternoon I implement floppy bird clone. I found there's some x86 assembler that is actually pretty amazing. Wanted to read the images, and then actually the whole afternoon was spent like reading the image files, because yeah. So in exact image, in today's open source enablement, exact image is now improved. Targa loading, which actually, fun fact, I could make a dedicated video also about. But because this exact image is more complex C++ code, it also means, because this is homebrew stuff, I want to also, with previous videos, this RX little and RX big system for Icebreaker and ULX3S, that I'm working here and have this vision of providing a really cool to work with modern RISC-V system with video and audio. That I also want to provide here a nice programming environment, as in modern C++, not like Commander 16 of 65 or something, assembler or something. So much more normal programming style, but for this still some small little stuff to improve, and also actually some hardware to do. So what we need to do is still the long running to-do list of keyboard and mouse. Also, fun fact with, where do I even have this cable? Should have it, here it's plugged in, of course. It should actually work on the ULX3S. Some other people are using this already with an OTG on the go USB cable directly, so not only USB without any physical transmitter integrated circuit, but also PS2, and the same we could also do for the Icebreaker. So maybe even just for the fun of it, in a couple of months we do our own PMOD for the Icebreaker. Maybe we even use the same for the as ULX3S is PMOD compatible there. But for the Icebreaker, we anyway need it here on the ULX3S. We can plug it in directly on the second USB port that's going directly to the FPGA lines. So yeah, certainly some time later USB, but for now PS2 anyway. So yeah, next really certainly USB and keyboard, because it's certainly what you need. But then also some smaller things, because right now the performance to stream video, of course, proof of concept, a lot of stuff is there, as you can see. but right now the performance would certainly not be like amazing or enough to even stream audio data from the SD card to our audio implementation, because on the SD card we need to read 512 blocks that take quite some time. So even if we clock it at 10 megahertz or 20 megahertz, which is possible, it's still quite some clock cycles to read in 512 multiplied by 8 bits. So that is quite some serial clock cycles are gone. So we need to improve our audio implementation. So either with a much larger FIFO, right now we have a FIFO of first in, first out, write buffer of 1. We could, for example, we probably could solve this issue just making this a FIFO with 16 entries. Super easy, just 5 minutes or so, and we are done. But maybe we just make it a little bit smarter. So there's often, well, certainly there's always like unlimited, like infinite kind of sort of nearly infinite ways to implement something. There are easy ways, there are more advanced ways, there are smarter ways. Something smarter would probably to implement either direct memory transfers, DMA transfers, so that the audio, our own audio implementation is direct memory transferring the audio data from some system memory, or alternatively simply interrupt support, so that with a FIFO depth of just 4 or something and interrupts, that the RISC-V CPU gets an interrupt to, for example, even interrupt the SD card reading, because interrupt, and then simply load the next audio sample, so that without DMA and without excessive FIFO depths, certainly interrupts much more smarter. In any case, we certainly for timing related stuff, even like OPL, FM synthesis, we want interrupt support. But yeah, you see always stuff to do. You also see the graphic glitches there, which it's not really like glitches, it's just like not implemented more memory. Ideally, probably for this RX32 big project, right now we are still like the icebreaker running 112K from the block memory from inside the FPGA. Although we have an SDRAM, I'm using this as high memory as in Amiga terms. So we have a whopping 64 megabyte SDRAM that I've implemented the controller and tested and it's working. Probably I change this also entirely, that soon on the ULX3S we will only run from SD memory and not the FPGA block memory, freeing 112K block memory, not wasting this that we don't really need. Running the RISC-V processor always from the SDRAM and or the ROM, the flash, and using all the block memory for the graphics, so that we can even make even fancier graphics, maybe even sprites, but also higher resolution, so that maybe even 640 by 480 8-bit palette colors like this is, and maybe even true color on this resolution, 320 by 240 true color or something, so 300 something kbyte graphic memory probably for the RX32 big. But all of those stuff always take an hour or two, especially if we want to parameterize this on the Verilog side for the icebreaker support as well. But yeah, I'm pretty happy with this progress, especially FAT reading. Certainly, as I always said, making here readable code. Of course, right now I showed this FAT. If you're new to this channel, FAT code, I have here some, not yet amazing, but at least somewhat more modern. I'm not yet entirely happy with this, but at least somewhat more modern than Linux kernel or something. And again, this is also, I said this already a couple of hundred times before, creating some new readable, like more modern readable code repository for homebrew and maybe even sophisticated microkernel projects. So right now, FAT a little bit starting point, and yeah, we still need to improve this. What I mean with more readable, not having, for example, endianness swapping and not using strange types or less readable like underscore U32, whatever, more standard types, and trying to make it easy for people to understand what's going on, and also easy for programmers to verify and work with this. So that's basically the update for today. Leave me in the comments below what you like to see. Probably the easiest to implement is some Tetris, Minesweeper, Pac-Man, some full-blown ScumVM or Doom port. Well, everything's possible, right? But as usual, leave me in the comments below what you like to see the most. I usually do here, for example, loading some test data. Yeah, as I said, I wanted to do Floppy Bird quickly, but as usual, quickly wasn't that quickly. But it's, yeah, you can vote below. I always take your comments and feedback seriously. Otherwise, I probably, yeah, as usual, not that much time here. Probably, I actually need to think what, certainly I will not implement a full Monkey Island here, but I make something that makes sense to me. Maybe even an audio player, maybe FLAC decode, maybe, because usually how I choose what to do is, well, certainly I knew I need fancier graphic working, so today this kind of graphic loading was like, yeah, let's make this graphic stuff more sophisticated. Palette writing, a full 64K plus larger. So this is why, by the way, 64K, the top picture is 64K. This is 320 by 200. Just the full picture, because even divided the 640 by 480 resolution that we're running evenly divided by 2 is the mode, the infamous mode X in VGA terms. This is 320 by 240. This is why there are 40 pixels random garbage at the end, because the Monkey Island VGA, not mode X picture, simply also not larger. But yeah, so what I usually do is what I want to see next for myself. That was certainly fancier graphic, but maybe just for the super fun of it, certainly I will improve the FAT code. I also need to debug this initialization glitches there. Then maybe make it an audio player, then I can sit here already and listen to some audio. Maybe even we have here some buttons, so maybe with some navigation and play all the WAV files and maybe FLAC. So maybe as a more sophisticated project, certainly next, makes this code API complete. That means having there some buffer cache and allowing to read non-block, like non-multiples of the block cluster size, which right now is a limitation. That means we certainly should implement some tiny buffer cache to have some API surrounding the whole 512 block reading, and then maybe even make the API start to prototype for others to have it easy, to have some standard API start to fill out here all the string and memory allocation function and try to compile the FLAC, the OGG Vorbis FLAC lossless wave PCM compression there, so that maybe instead of WAV files we can play more fancy FLAC files. That certainly would probably, well, even that is a rather large task. Probably it takes, maybe if I'm lucky, a day or even a whole weekend to implement as much API of ANSI POSIX stuff to have as much from scratch firmware, because this is running bare metal, right? Without an OS, bare metal on the RISC-V core here on the FPGA. So this is all bare metal firmware, and just implementing as much API stuff that, again, we can reuse on DOS, previous videos, or microkernel stuff that we can compile the FLAC library, for example, as a first test for this. And certainly that is a rather large task. Certainly, probably it makes sense to first have a little bit of game like Tetris, or Tetris is probably the most easy. Just make a super simple blocky Tetris. A real full-blown Pac-Man, certainly a little bit more works in Tetris. The Tetris thing, we could probably, the easiest to have here some low-hanging fruit of what can you do in maybe 2 or 4 hours. Simple Tetris. A fancier version would we have already OPL, like audio output, previous videos. So more fancy version would be like Game Boy, like Tetris soundtrack there, and then maybe FLAC audio music player and stuff. VGM, GME or VGM stream, yeah, so VGM we have already, so this previous video, VGM playback of 10Ds. We have basically, I have kind of feature complete previous videos, VGM playback. I have already this, and actually I can show you this also. Can't really, you could do the video, the audio player and have VGM support. So VGM parsing is already here. So I also implemented VGM parsing here from, at least, well, VGM parsing for the 10D SN, 10D 1000 PC Junior or other previous videos if you want to watch this already. Fun fact, as I cannot make a video and stream each day when busy and stuff, you can always go into the archive and look on the content what we have already. So you have some basic VGM stuff for exactly this here. Also next I need to start factoring out the stuff to have a really one file for each function, and maybe even programs. Also, yeah, probably sometime soon we need to start having program loader support so that we can have like on a real homebrew Amiga, Commodore or something system, different executables, so that we have soon keyboard here and that you can have some startup firmware stuff and can audio video player game and stuff. But yeah, so VGM already done. It's basically just like making all the stuff, like really polishing it, the bits and pieces, making it separated programs, yeah, wave player. So if we probably soon, I should really basically this would be ELF loading, just with some like ELF RISC-V ELF binaries, and just instead of compiling them all in here, having them in the file system and have some basic ELF loader to have to load them, to load the ELF object for this super tiny homebrew system anyway, like Amiga-like, and support loading ELF files, like, yeah, compiled ELF binary objects, loading them to some predefined loader address and having them run so that run and exit and have this firmware. But anyway, so this are there you see also for you to have an vlog-like experience of how much does it take. First the basic enablement, writing all the hardware RTL definitions and Verilog, getting all the hardware to work, audio, video, testing all of this, and then step by step with some easy firmware. Right now the firmware is right now one ELF object that gets converted from ELF to direct binary object and loaded here into the flash, and we are running this right now from the serial flash SPI flash. But yeah, there you see all the project milestones of first hardware enablement testing, and then step by step improving on this, and certainly then the more sophisticated bits and pieces, the more stuff gets tested and stuff. But anyway, that's it for today. Probably still video coming of dedicated walkthrough of FET. Of course, nothing stops us also to implement ext2 and BetterFS and Riser and all the other fun stuff. But of course, initially FET is enough. And then, yeah, I hope you enjoy this project. This is insane project of not only homebrew firmware, but in the long term, microkernel stuff here, even on x86 and so on. As always, happy that you tuned in, and don't forget to share, like, and subscribe, and leave a comment below what interests you most, what you like to see. And yeah, theoretically, I just probably I actually packed the line cable away. One small note, one thing is a little bit strange. I need to analyze this another day. On the ULX3S, it has 4-pin TRRS audio jack output here, and I thought it should be compatible with good old-fashioned headsets here and modern headsets, because modern headsets have a 4th pin or a second ring TRS. And what is strange is with a modern headset, like iPhone compatible, it works left and right, but no, usually this iPhone stuff should also work with old-fashioned, but old-fashioned TRS doesn't have a right audio, so I'm not sure if this is by design or if there's something. In any case, that is slightly inconvenient. Probably I should, because they want to crowdfund this sometime soon, crowd supply this sometime soon. But I guess they don't change something anymore. But in any case, we could at least solder us a connector. I have 4-pin TRS here in stock. Either we solder us a converter, or we figure out what's going on with that, if we can improve this somehow. If this is the right ring, just a little bit of tiny shout out here, but yeah, the small little details always. Yeah, I don't have the line cable here. I packed it away because keeping the office sorted. Otherwise I could have finished here with some audio, but previous video. Thanks for tuning in, and I hope to see you soon for all the next videos and fun FPGA hardware and software stuff to come here on this channel.